There are a lot of reasons to avoid 6-meter EME. The first one is a high degradation that we have on 6 meters. When the degradation is a combination of the distance to the moon plus the high noise behind the moon. And the degradation from the distance to the moon, it goes in and out from the Earth every month. And that's about 2 dB in itself. So even the people that talk sideband on 1296 EME, they have to worry about the 2 dB. But we have to worry about the noise behind the moon on 6 meters, which adds another like 12 dB. So since signals are barely perceptible on 6 meters anyway, the degradation on 6 meters really limits activity on EME to like a week per month. So it's you really have to watch that. And also on top of that, then the signals are very easily disrupted by any kind of ionospheric aberrations. They may not be high enough MUF to send the signals back down to Earth again, but they're certainly high enough to send them off course from going to the moon. And so any high TEC areas over in front of your antenna can be a problem. This is especially true for people who are horizon only, because obviously they're pointed at a much more oblique angle, and so any kind of scattering happens more easily for their signals. There's a problem also with the horizon only people. They can get trapped by tropo if you live someplace where there is tropo. We don't have that out here in Montana, but I remember running, Paul, you'll remember this. I remember running 6-meter EME skeds with K8II in Ohio, and I'd copy him on his higher lobes fine. And when the moon got below 10 degrees, I could never hear him. And it's just because, you know, the tropo back there, it just captured all of his signal. Also, one of our big problems on 6-meter EME is high local noise sources. Just about anybody who lives in a city is out of luck, because they say, oh, well, my S meter only reads like S1. And when you put a preamp on it, it should read like about S1 and with no signals. So they've got like S4 or 5 noise often in big cities. And the people in the urban areas that I've run with, I always hear them, but they never hear me. So signals on 6 meters are extremely weak, almost always inaudible. Then on top of that, you got the problem of Faraday rotation, changing the polarity as the signals go out to the moon and come back. So often they will arrive at right angles to the polarity of the polarization of your antenna. And so you lose 22 dB there. So when the signals are just barely detectable to start with, losing another 22 dB doesn't help. So the signals between stations, for that reason, are very rarely reciprocal, which is why we have to run schedules, and it takes often an hour, because you have to wait for the moon to, especially with a horizon-only station, to wait for the moon to move down in front of one of its ground gain lobes, and then you have to wait for it to move into another ground gain lobe when hopefully the polarity might be lined up right so you can hear him. And so there's a lot of complications. And basically the antennas never seem quite big enough to make it work. So the contact rates are slow. It's not like a DE expedition on HF where they're planning hundreds of contacts an hour. You might get one contact an hour. If you're lucky, you can do a little bit better than that. And so by and large, this is the worst possible band for EME. However, there are those of us who live in RF black holes who have to point our antennas up at the moon because it's our only option. And so there are some reasons why 6-meter EME works. The big reason it works is that in 2002, Joe Taylor miraculously provided 10 to 15 dB over CW. And that made single Yagi stations viable on 6-meter EME. And the other reason is more people around the world are capable with 6 meters than a lot of the other EME bands. It isn't like 1296 or 2300 where you need all this specialized equipment and test equipment and wave guides and things. People all over the world have rigs with 6 meters. And more commercial rigs and amps now include 6 meters. It's easy for people to buy a kilowatt amp for 6 meters and get on the air. So that's part of the reason we're having such a huge increase in the number of 6-meter EME stations. The antennas now are computer designed, which really helps us a lot. And the equipment developments in the cell phone industry and other electronics with the feed lines, the connectors, the 7/16 DIN connectors are just wonderful. The power transistors and the preamps and all of that in the last 20 years has just taken fantastic improvements, and that has all helped a lot. And the computer advances go back into the 2002 period where Joe gave us this great computerized digital stuff. And now the computer advances really help it. Now with the latest WSJTX, they have 64-bit versions, so you can run them on your 64-bit computer, and the processing is just fantastic. So 6-meter EME is attractive also because the forecast for the next few solar cycles, the only ones that probably I'll live to see, are not that great. And we don't have to, we might not even be around for the next good solar cycle. And for us in high geomagnetic latitudes like Western Montana, EME still works. It seems like I'm almost always a hop away from the propagation from the guys down in Colorado, New Mexico, and Arizona, who often get into TEP. Certainly in Florida, they're always into TEP. But up here, it always seems to be at least one hop away. But with EME, even we can get in on the game. One other thing is that a lot of the propagation that's taking place on 6 meters, we don't know what the links are anymore. There are so many satellites up there, not right now, but also jet airliners that provide links to propagation. Back in the last solar cycle around 2001, I checked out the paths of the International Space Station, and I was hoping it was going to be coming by the West Coast at a time when there would be propagation to South America, and so I was hoping to use that as a link to get into the TEP. And I did. In fact, I heard for about 10 seconds, I heard the low band of the low end of 6 meters sounded like 20, and then it was gone. So there are a lot of fast links available that provide propagation links for us. But the EME is an all-natural way to do that. And there's a very rapidly growing worldwide 6-meter EME community. I've worked 165 countries on 6-meter EME so far. Out of the 221 that I've worked, that the 165 have been on EME. So there are more and more people getting on EME. And if you're into DX, that's 500,000 miles with every contact. This is the backyard of an avid VHFer on EME. That's right out here. Now, the requirements for a real 6-meter EME station, what I call a real EME station is one that can contact a similarly sized station, is a 14 dBd overall antenna gain, and that could be made up with perhaps up to 6 dB of it can be ground gain if you're pointed at the horizon. So a lot of the stations that we work on 6-meter EME are horizon-only stations that have a clear, open ground in front of the antenna, and they can get antenna lobes which peak at 6 dB more than their antenna gain. And you need 1,000 watts. A quiet QTH is paramount. If you have feed line loss under 1 dB, then you can put a good low noise preamplifier in the shack, which is what almost everybody on 6-meter EME does. During the quiet times of low degradation, the preamp in the shack really makes a difference. You have to have JT65A mode capability, and that's usually with WSJTX because it has the EME modes built into it. And virtually all 6-meter EME uses JT65A mode. You're going to need to do a lot of planning to determine when you have mutual moon with different stations, and you've got to have a lot of patience. As I said, most single Yagi stations with flat, clear terrain around them can generate the extra ground gain to make the link possible for them. But they're limited to when the moon is below about 15 degrees elevation. So here's an example of a single Yagi station. YU70F has designed a number of single Yagis for VHF, and I've worked him on EME with 7-element Yagis, 8-element Yagis, 9-element Yagis. This is his current 9-element Yagi that he's using. He's horizon only, and because he's got a single Yagi, he has a couple good ground gain lobes, like around 7 degrees and 15 degrees elevation as the moon passes down through it. Of course, the very best ground gain is when you can look out over the ocean like this, and then you have a negative horizon due to the curvature of the Earth, and you can have an extra ground gain lobe right around 0 degrees. I've on DXpeditions, not from Montana, I don't have that kind of horizon, but on DXpeditions, I've copied signals down to -1.5 degrees. So even single Yagi stations are sometimes frustrated, so there are more and more people elevating single Yagis. that still limits you primarily to working the larger stations. So I designed a very simple, easy to build, hinged mount for single Yagis. This is the one that I'm currently using for my portable operations. A lot of people have duplicated this. It's really easy. There are only a few parts, and all the weight is over the mast, and you can go quite high with it. So it's a very useful mount for single Yagi, but you're really limited as to how high you can go and who you can work with a single Yagi. So if you really want to be able to elevate higher and work smaller stations, it's not that hard to put up an H-frame with 4 small Yagis. And about the smallest that you'd want to go to get your 14 dBd gain, since you lose all ground gain when you elevate, and you still want to have around 14 dB gain, is the 5-element M² antenna. Or you can go with the MFJ Cushcraft 5-element loop-fed Yagi, which is actually even slightly more gain, you can see here. And the cost is, you can see, is a couple $100 less. So you're almost getting 2 for 1. And these are the Yagis that K5NA and K5DU recently put up in a simple H-frame. Just requires one truss line here and a pair of trusses on the cross boom. The antennas themselves don't require any trussing because they're so short. I mean, I think they're around 20 feet booms. The antennas themselves are like 16 pounds. So it's a quite manageable array. KX5I operates his station in Nevada remotely, and he's using also 4 of the 5-element LFAs. So it's not that hard to put up a little H-frame. If you want to make contacts with even smaller stations, though, you can do like N0TB just did, and he put up 4 8-element LFAs, which is a little bit more substantial. And he put up a very substantial elevation system for that, where he rotates a tower using a prop pitch motor. And the same elevation system was also used by KJ9I on his brand new 4x10 element LFA array. So we're very much looking forward to having these on the air for this. This will be the first month of good conditions in next week to have these guys on the air too. So like I said, these are brand new, but there are people in Europe and in Japan who are also putting up big arrays. We even have a couple of arrays that are cross-polarized, so the Faraday rotation won't lock out the signals. F6BKI has 4x7 element LFA Yagis that are cross-polarized. The cross-polarized arrays get much more involved because the masts have to be insulated. All the phasing lines have to be behind the reflector, or they'll interfere with the pattern. So it's mechanically much more challenging. HB9Q just put up a 4x7 X-pole array with a very unique approach. He made two boxes out of fiberglass to support the antennas, and ran all of the phasing lines back behind the reflector on these fiberglass boxes, and then up to the power divider. So he elevates the boom this way. And he always transmits circular polarity, so we always hear him no matter what's going on. And then he does what's called adaptive linear reception. So his receiver automatically selects the correct combination of polarities to decode the signals between the horizontal and vertical components. So with more and bigger 6-meter EME stations to make up the gain on their end, there is more incentive for single Yagi DXpeditions, and they can be even smaller. And even HF DXpeditions could add 6-meter EME to their operation. And just in the last few years, HF DXpeditions that I have worked for new DXCC on 6 meters include these stations, and I've worked other HF DXpeditions before that, which took along 6 meters. Then on top of that, of course, you have dedicated 6-meter DXpeditions. So how did I ever get involved in this ridiculous endeavor? Paul was saying before that I've gone to a number of places. I've been on a bunch of 2-meter EME DXpeditions before I got into 6 meters in 1996. In December of 1995, here I am, I almost killed myself hiking in a hiking accident. So I decided, well, if I'm going to live, it's time not to wait on 6 meters any longer. So I ordered an IC706, and while I was on crutches, I built an 8877 amp, and then I built a 7-element Yagi using a 2-inch irrigation pipe, irrigation tubing, and I was up for the first E-skip season. Here's my 7-element Yagi in the trees on up 20 feet, and it was fed with surplus 75 ohm CATV cable. That was in April, and of course since I had been working 2-meter EME for a few decades before that, I decided, gee, I'll have to see if I can work EME with this. So for 3 months I tried, and finally in October of that year, I worked SM7 BAEs, 4 or 8 Yagis, whatever. I think he had 4 big Yagis on 6 meters. And that was during my moonrise. So I decided, gee, this is good. Need to do something better. So in October the next year, I built a homebrew 13-element Yagi that I could elevate up to 13 degrees or 45 degrees. You can see the guy lines here are the limiting factors. You just can't raise it up that high. But it turned out to be big enough when a thunderstorm came through in the summer of 1998, and I came home after seeing all these limbs across the road and thinking the worst, and by golly, there was the worst. 2 halves of this Yagi were hanging off the top of the tower. So I replaced that with an M-squared 11-element Yagi, which had about the same amount of gain, almost 14 dB gain, and elevated it again up to 45 degrees. But you know, I found that was almost when moonset was starting in Scotland. And so I couldn't work them very well. So I thought, okay, I need something that where I can elevate it up higher. So in 2001, I put up 4 of the 50-foot long 6M9 KHW Yagis from M Squared, phased them with LMR 600, fed it with 1 5/8 heliax, and the center of the array is at 32 feet. And I can elevate that up to about 70 degrees, which is all the higher that I need to at my latitude. And in April 2002, thanks to Joe Taylor, JT44 mode came on the scene, and I worked ZS6WB with my single Yagi to his single Yagi during his moon set and my moon rise. And I was just so amazed that we were able to make a contact using this brand new digital mode, because I'd been struggling with CW on 6-meter EME with everybody, that I demanded we set up a schedule for the following weekend, and we worked again the following weekend on different lobes. So I was hooked at that point. And so in 2005, I got my 6-meter DXCC. I'm now up to 221. Then in 2007, I had metastatic melanoma. And after 2.5 weeks of testing at the NIH in Bethesda, Maryland, they determined that I only had it in my liver. And they decided, oh, we can't treat you for it, so you'll be dead in 2 months. So I guess we'll take it out. So they took it out. Yay. And so after that, I said, well, now with this new lease on life, I'm going to give DXCC to a lot of the serious people who are getting interested in 6-meter EME. So I talked to M Squared, and I said what I need is a gain of at least 12 dB over dipole, and something that can be easily transported on airplanes and put together and taken apart repeatedly without galling aluminum or anything else. They came up with a 6M8GJ, which is 43 feet long. And that's what I've been using. So in May, after I recovered from my operation, we went to Italy to celebrate while the 6M8GJ was being developed, and looked at the 4x7 array that I had worked at IW5DHN. And he said, oh boy, yep, this is a growing thing. Here is my parts for my new antenna. It's going to be 4x9. And that's what he's got today. So the following year, the 6M8GJ prototype was ready, and I headed off to the Cook Islands to Rarotonga on my first 6-meter EMED expedition. I worked 28 big stations, which I was thrilled with at the time because there wasn't that much activity. But I also went with ZL1RS, who is operating 2-meter EME. And, you know, I mean, he'd worked like 200 stations on 2-meter EME at the same time I was operating 6-meter EME. So this is what Rarotonga looks like. You might not think it, but I did have good ground gain to the west on my moon set, because I had this big flat area before the mountains went up. And so my ground gain lobe was up above the mountains. So that worked out fine. And here's a picture of the prototype 6M8GJ on a tower that we borrowed down there, and raised it up 20 feet. And I made a little elevation mount that I had used on all of my past EMED expeditions, so I could elevate it. And I consider this to be a sub sized EME station because it's just a single Yagi, but I'm able to work the larger stations, and also when on my moonrise, when I'm pointed out over the water, I've got ground gains so I can work even smaller stations. This prototype is now used on 6-meter EME expeditions by ZS4TX, and he's activated I think 3 or 4 DXCC down in Africa now on 6-meter EME using this antenna. And we did have time to view how coconuts are used in Rarotonga before we left. The next year, I worked 52 stations on 6-meter EME, which was a big improvement. This again was a DXpedition in conjunction with ZL1RS, who operated 2-meter EME. And we operated from the north end of Viti Levu, which is the main island of Fiji. And there's the 6M8GJ elevated up at the moon, as far as I could get it up there without interlaced in between the guy lines and everything else. And that was our shack. The following year, I worked 44 stations on 6-meter EME, plus 1 station on ionospheric 6 meters from Samoa. And there's where we stayed in the northeast corner of the island of Savai. And the antenna was set up on a lava flow overlooking the bay there. And you can see the wooden fence. That was basically where the water came up to during high tide. So the antenna from about here on out was hanging over the salt water during high tide during my moonrise. The following year, I worked 46 stations on EME, plus 33 on ionospheric propagation from the island of Niue, which is called the Rock of the Pacific. It's just this limestone butte that sticks up out of the ocean. And there you can see my wife in the corner snorkeling in one of the freshwater / saltwater pools at the edge of the island. And almost everywhere I go, I have some obstacles to try to work around when I have to figure out where to place the antenna, how to elevate it up through the trees and bushes and buildings. This was no exception. The following spring, I went on the TX5K expedition. I worked 50 stations there on 6-meter EME, which I was very, very pleased with. 265 stations on TEP, mostly on sideband, but I did work a number of CW. A lot of the people in South America would say, okay, now I want CW. And so I'd work them on CW also. All of the EME, of course, was on JT65A. The only reason that operation on 6-meter EME worked along with the HF operation was the HF people decided to set up here as shown on the map, and I decided, okay, that means I'll go down the beach as far as I possibly can go, set up the 6-meter site down south of them. So I'm pointed at right angles to them on my moonrise, pointed at right angles to them on my moon set, and I'll point away from them when I work TEP to South America. And it worked great. I wasn't able to interlink with their with their real-time logging system, but we were able to upload the logs later and combine them with their system. We were far enough apart that we never interfered with each other. And it's hard to tell because they're all falling apart, so I can't count. And here's a movie showing how I got the stuff to that location. And Paul, can you run it from your end? I'm not hearing anything on my end. Paul, do you have
I can hear it.
the audio on?
No? Okay, let me see if my share's working. Sometimes I gotta. I hate this technology. Let's see. I can hear it on mine, but you guys can't hear it.
I think you got it.
What?
I'm hearing birds.
I can hear birds.
You can't see anything.
Yeah, there are about 100,000 birds there.
I don't know why you guys can't see it. Let me stop this for a minute to see if I can figure out how to get back.
Well, we can skip it, Paul.
Okay. You can go back.
Anymore. Anyway, this was the aerial view of the 6-meter site. This was the operating tent here, and I had to put a large tarp in the open-ended end of the tent to keep the salt spray out of all the equipment. There was the pounding surf right here, and you can see the antenna shadow just in the lower right-hand corner of the screen, just barely. The salt spray never stopped. The prevailing winds were in from the east, or yeah, they were in from the west. No, they were in from the east, and so the spray was never ending here from the ocean side. After the first day, the computer screen on my laptop gave out, so I had to borrow a USB keyboard from the HF group, who were down here in the distance. So it was an interesting trip, but it was successful as far as 6 meters is concerned. There I am adjusting the elevation on the array, and you can get an idea of the neighbors that I had. The boobies are ground dwellers. There were no trees, very few trees on the atoll at all. And the crabs overran everywhere, and they ate the boobies, and they ate the booby eggs. And the rats have been that landed on a crashed Mexican fishing boat there at the turn of the century are rapidly eating the booby eggs also, and so they the dynamics are changing on the island because of that. There's the reef around there is very, very difficult. The following year, I went to American Samoa, and I had been looking at that for a long time because it was a rare spot. A lot of people needed American Samoa. It was easy to get a license to go there. And I went along with, again, with ZL1RS, who you can, his 2-meter EME array is here at the closer to the building. I finally found this spot and wrote a proposal to the National Oceanic and Atmospheric Administration and submitted that, and they allowed us to set up at their atmospheric observatory on the northeast peninsula of American Samoa. And here I am 200 feet above the ocean assembling my antenna. You can see the mast is already up. And at night, the crabs came out, and the flying fox bats also came out. And now I'm the following year, I decided to go another place that was easy to get licensed for, but was very difficult to get to. And that was Micronesia. And I studied for a long time on Google Earth where I might be able to set up that had enough clearance to set up a 43-foot long 6-meter Yagi. Micronesia is very heavily tropical forest everywhere. And what isn't tropical forest is developed. And so it was very difficult to find a place, but I did find a spot at a resort. It was a building with a few rooms you could rent on Falalap Island in Ulithi Atoll in the westernmost state of Yap. And I was able to get on a Christian airline that ran weekly humanitarian supply flights to Ulithi Atoll. You can see there's a big airstrip here on Falalap Island because it's left over from World War II. And so I made 37 6-meter EME contacts and 5 ionospheric contacts before the AMP blew up after 1.5 moon passes. This is where I stayed and set up the antenna. So I was planning to stay there for 10 days, but since the AMP blew up and I couldn't work anybody, and they had a brand new merchant ship which was coming the whole way through Micronesia, it was coming by, and it had anchored off the coast of Falalap Island. I decided I'll take that back to Yap, and I put my suitcases out on the beach, which was the sign for them to come in with a dinghy and pick me up. And I took the merchant ship for 2 days back to Yap. The following year, I worked 49 stations. So you see, it's getting a little bit better. It's still right around 50. In 2016, this was 4 years ago, I worked 49 stations on 6-meter moon bounce plus just a couple stations on ionospheric propagation from Palau. And I had run schedules with many JA stations who went to the VIP Ham Hotel in Koror down here in southern Palau. And I always copied them, but they never heard me because of all the noise there. So I picked a place up in northern Palau, which was the skinniest part of the island where I could see both oceans on moonrise and moonset. And it was outside of the little village of Chol. And do you want to try this one, Paul?
Okay, I think the problem was before that you were still sharing, and I think I can only one of us can share at a time. So
I have stopped sharing.
okay, let me go with the video here, and let me just put it on hold for a second so I can hit the share screen. Okay, and
This is the way I put up the antenna everywhere I go. And I had to do it by myself here in Palau because my wife was out looking for 220 connectors for me.
sorry, I got the wrong one here.
No. Yeah.
Is this the one?
No, that's the wrong one.
That's what I just said. That's the wrong.
It's an island.
What we're doing great here, aren't we? Let me just go back here to let me get rid of this guy. Okay, and it's which one is it? The it's the
the
solo, right?
antenna array,
There you go.
T8. And this is how it's done. It was very windy there because it was the outskirts of a hurricane that was hitting the Philippines, was battering Palau. So I oriented the antenna so I could raise it with the help of the wind. And I always try to set things up so that I raise with the prevailing wind or raise it downhill. And as you can see, I use a falling derrick, which is also all assembled in 44-inch long pieces in my luggage. And that's how it's put up. Thank you, Paul. Maybe it came across better from you than it does from me.
You're still not finished yet. You're still messing with the cable lines. You got to guide this thing down before it falls again. Oh my God.
I've got a good handle on it there.
Holy smokes! I can't believe you did that. Okay, you can share. You can start sharing now.
Okay.
You guys all see that? Okay. Anybody not? I guess it worked.
Did it come across okay?
Oh, you saw it up there.
Here's what it looked like when it was up. There it is. It's next. The building that I was operating out of was a community storm shelter, disaster shelter, which they also use for weddings. And we stayed in one end of it and set up the shack. But of course, then I had to get special dispensation from the chief of that area to rent this from them. And they had an important wedding the following weekend, so we had to go sightseeing. And I had to tell everybody that I was off the air the following weekend while a wedding took over everything. But it's always something. Here you can see on the right-hand side of the screen, there's a power pole, which caused me a lot of trouble on moonrise when it was not raining. When it was pouring rain, it was wonderful. It was very quiet, and I shot right out over the sea to the east, and I had great ground gain, and it was no problem at all. But when it stopped raining, That was a problem. The next year, oh no, the next month, I went back to Follow-Up Island because feeling bad that I'd only had 1.5 moon passes. There were a lot of people who were still anxious to work me. So I worked 43 more people when I went back there for the second time. And the second time I had to get special dispensation from the whole chief's meeting of the outer islands. But luckily they were meeting in Yap just before I was to board the plane. So the pilot and I went down to the meeting, and the head chief said, "Oh yes, so we've heard all about you. You're not a tourist. You're taking all your own food and everything. So yes, of course, we'll sign this special authorization so you can get on the airplane to go to Follow-Up Island again." So I went, and it was still very, very devastated from the cyclone that had been there 2 years before. But I was successful on EME, and I set up in a corner of the room where it wasn't leaking through the ceiling, so I could keep the equipment dry. And the following year, I worked 86 stations on 6-meter EME, plus 1 tropo contact from somebody who had a 6-meter rig on the island. And that was from Cocos Keeling Island off the west coast of Australia. And that was the best I had done so far. And that was still a very difficult spot because the window with North America was very limited. But one of the high points of the trip was this orphaned booby who was just starting to get its white plumage. You can see on its head, and it was just starting to learn how to fly. They have to become quite large before they have the strength and the size wings to fly. So my wife made him quite happy by throwing him into the air, and he would glide to the next picnic table or whatever and practice his flying. And from there, we went the next month to Christmas Island, which is also owned by Australia, but it's most known for crabs. And this was the biggest crustacean in the world. I saw my first one at night while I was outside the shack going out to turn the antenna, and he was in the doorway. It really was kind of shocking, but they're about the size of chickens. And there I worked 106 stations on 6-meter EME. So it's the first time over 100, plus 1 tropo signal, tropo contact with a VK9 X, I think was their, it was an HFD expedition, but they could load up something on 6 meters so that they gave me a contact so I could work VK9X while I was there. And they are filled with lots of wildlife there on Christmas Island, but the big attraction, of course, were the crabs. And the red crabs are the famous ones that they have millions of that migrate every year in November. We got in just at the beginning of the migration. We could see how they migrate down to the ocean through these special, like, cattle guard tunnels underneath the roads to get through the forests down to the sea. And there's where I set up in the kitchen of the Christmas Island Cricket Club at the highest point on the island. So I was 1,200 feet above the ocean. And I really had very limited windows to North America from there. It was my moon rise and my moon set to their moon rise and moon set. You can see the little danger RF radiation sign that I always put up on all the entrances to the where I have the antenna set up on my DXpeditions. The next year, I worked even more, 119 stations on 6-meter EME, from a very rare spot in Nauru. It's very difficult to get to, very difficult to get a visa for, which you need before you can get a license. Here is typical of the equipment that I had to take. This was a solo expedition by myself, so I had to carry all the luggage and pay all the extra baggage myself. And it was a challenging spot to try to set up the antenna, kind of a tight spot between containers and their boundary property fence. But I found a spot to set up, and it worked out fine. I had moonrise out over the ocean. The next year, I worked 111 stations on 6-meter EME, plus 19 on TEP to E-skip from Bolivia. And here's where I set up in the courtyard of the hotel while the alpacas took care of the mowing the lawn, and they would move around when they weren't free ranging. If they needed a special lawn control in a certain area, they'd tether them in certain parts of the courtyard. And the following year, which was last year, I worked 106 stations on 6-meter EME plus 1 tropo station, which was 30 miles away on 6-meter FM from the Seychelles Islands. And the only place I found in the Seychelles Islands with enough space to set up my big 6-meter antenna was on Ladigue. There were 4 bungalows that were available to rent in a national park on Ladigue. And so that's the spot where I set up the antenna. And there I am adjusting the elevation. And there were lots of tortoises in the Seychelles Islands. This year's DXpeditions were canceled because of COVID-19, but in October of 2021, this is my location on Rimatara, I think is the name of the little island. It's a postage stamp of a little island in the Austral Islands in French Polynesia. And this is north, is off to the left in this picture. So I'm looking out over the ocean on moonrise and out over the ocean on moonset. And I'll be beaming up out over the empty runway for all the moon passes. The development is over here on the island and down here, so it shouldn't be much of a problem. And then in November of next year, I'm licensed as TX7MB, and I'm going to be joined by KB7Q from Bozeman, Montana. And he will be operating 2-meter EME at the same time as I'm operating 6-meter EME from the Marquesas using this call sign. And we recently changed our licenses from 2000 to 2021. They're all received and all okay, and changed the reservations. for the accommodations. And next month, I'm going to change the airline reservations when they know what the schedules are for 2021. So the bottom line is there's endless DX propagation now on the Magic Band, and I am disappointed now if I don't work over 100 stations on 6-meter EME, even though it was just a short while ago that I was thrilled to work 28. And the reason for that is because there are so many people getting on and such big antennas. And so if you're interested in finding out more about 6-meter EME, there's a lot of information on my website. That's W7GJ. I'm good on QRZ.com. You can also sign up for the Magic Band EME email group, and you can do that on my website. You can also, all of the real-time scheduling for 6-meter EME, you can look and see what's going on. We all meet on the ON4KST EME chat page for scheduling the 6-meter operations in real time. And that the activity usually centers around the best days of the month for EME. And you can find a list of those best days of the month on my website. And also it's next week. So stop by the ON4KST page next week and you'll see who's working whom on 6-meter EME. Are there any questions? If not, see you on the moon. Thank you very much.